In this video, we're going to complete example 3. We're going to learn how to multiply and divide algebraic fractions. Now, I've got a few dot points to go over, so I'm just going to go to a blank page, and I'm going to remind you how to multiply and how to divide fractions. So let's say I had 2/3 multiplied by 3/4. Multiplying fractions is really simple. You just multiply the top two numbers, 2 times 3, which gives us 6, and then multiply the bottom two numbers, 3 times 4, and you get 6/12. Dividing is also easy. Let's say I had 2/3 divided by 3/4 this time. The only thing that changes is you flip the second fraction. So we're going to keep 2/3 as 2/3, and we're going to change the 3/4 to 4/3. So we've flipped the second fraction, and we're going to change the divide to times. And now we can multiply it. 2 times 4 is 8, and 3 times 3 is 9. So these first two dot points, which are basically illustrated below, are really simple. It's easy to multiply fractions, including algebraic fractions, and it's easy to divide algebraic fractions. But what's hard is the simplifying. Okay, and the pointer I'm going to give you as we go through our examples is not to expand expressions straight away. And the reason we do that is because we want to see if we can cancel first. And you'll see what I mean as we go through the examples. Alright, now on this slide I only have 2 questions. I'm actually going to be covering 6 questions in total. So we're going to end up on question F. So starting with question A, 5x squared times 9. Now 5 times 9 is 45. So we're going to get 45 x squared. And then for our denominator, 3 times x gives us 3x. So we need to simplify this now. 45 divided 3 is 15. So that works out quite nicely. We'll have 15 at the top of our fraction. You'll notice we've got 2 x's above and 1 x below. So if I was to write my 2 x's above and my 1 x below, I can quite easily cancel one of each x, leaving me with 15x. Now I know most of you are probably going to go from this step straight to this step here. The one in the middle is just for me to illustrate what's happening. Most people don't actually include this step. Let's now move on to question B. Now this is division, which means the first step is to flip the second fraction and make it multiplication. So the first fraction stays the same, 3/10y z squared. We're going to change it to multiplication and flip the second fraction like so. Whenever you see a question involving division, that's the first thing you do. Flip the second fraction and change it to multiplication. Now I need to apologize. My z and my 2 look very similar to each other. This is one of my weaknesses. My weakness that my z's and my 2's seem to look very similar, and I do apologize. So let's combine our two fractions now. 3 times 20 is 60. So we get 60 up above. We've also got the y and the z. Y, z. And for our denominator, 10 times 6 is 60 as well. And here I've got y and 2 z's, or z squared. So I'm actually going to write it as y, z, z. It just makes the cancelling a little easier. So cancel my z's. And I can also cancel my 60s. Oh, and also my y's. You'll notice that we're left with only one z, which is actually at the bottom of the fraction. So what do I put up here? Do I leave it blank? Do I put the number 0? I actually need to put a 1. And in case you're not sure why we put that 1 there, it's because technically 60yz is the same as 1 times 60yz. And then by cancelling everything else, I'm left with 1. Now once again, this looks like 1 over 2, but it's 1 over z. As I said before, my z's and my 2's look very similar. I should probably pick questions without z's in them. Now before we move on to question C, I want to talk about some technical terminology here. I keep telling you, when you divide, to flip the second fraction. Whenever you flip a fraction, there's a technical term you're supposed to use, and the term is this: reciprocal. So when we flipped this fraction here, we turned it into the fraction here. And we refer to this fraction, 20yz over 6, as the reciprocal of the fraction 6 over 20yz. So if you ever have a question where it asks you to find the reciprocal, it's basically just asking you to flip the fraction. Alright, moving on to question C now. This is division. So the very first step I want to make is to flip the second fraction. So the first fraction stays the same. I'm going to make it multiplication. How do you flip something that's not a fraction? Well, you might remember that the number 2 is the same as 2 over 1, or 2 divide 1. So is the number 5. It's the same as 5 over 1. So I'm just going to change my x. So it's x over 1, which when flipped becomes 1 over x. So let's multiply the top two. If you multiply something by 1, it remains unchanged. So the top of my fraction is just x, y plus x, z. And then for our denominator, 5 times x will give us 5x. Now we're at the stage where we want to simplify our fraction, and when you've got two terms separated by a plus or a minus, that indicates to you that you need to factorize it. So we'll do that. What's our common factor here? Both these terms have a common factor of x. So we're going to factor out our x, and x times y gives us xy, and x times z will give us xz. And then 5x for our denominator, and we've got a common factor here of x. We can cancel out our x's, giving us y plus z over 5. Alright, we'll now move on to question D. We'll start by multiplying the numerators here. We're multiplying 5a plus 10 by x. So I'm going to put 5a plus 10 in brackets, because you need to remember that you're multiplying this whole expression by x. Now let's do the denominator. This time I'm multiplying 15 by a squared minus 4. So I need to put a squared minus 4 in brackets because the whole expression is being multiplied by 15. Now we're not going to expand the brackets, or at least not yet anyway. And the reason we're doing that is because we're looking to cancel, and when you're looking to cancel, you want things factorized. In fact, we're actually going to focus on factorizing here. What are some things that you can see that we can factorize? Well, I can see a difference of 2 squares here, so I'll actually start there. I'll keep my 15 as 15. I've got a minus sign and 2 terms that I can square root. So if I square root 4, I get 2. And if I square root a squared, I get a. So I'm going to have 2 sets of brackets with two terms, a and 2. Both sets the same. One's a plus and one's a minus. So I've been able to factorize my a squared minus 4. Can we factorize something on the numerator? Well, yes. For my 5a plus 10, I can factor out a 5. Now, I'm just going to do this in green just for now. I would factorize it as 5 bracket a plus 2. Because 5 times a is 5a and 5 times 2 is 10. But what do we do with this x to the left? Well, I'm actually going to put this x next to my 5. So I'm going to have 5x bracket a plus 2. Okay. Now already we can see something that we can cancel. We've got a plus 2 above and below. So let's cancel that to start with. I can't cancel my x, can't cancel my a minus 2, but I can do something about this 5 and 15. Because 5 over 15 is actually the same as 1 over 3, if I simplify it. And if you're not sure how I did that, well, I just divide both the top and the bottom by 5. Okay, so if I do that, 5 divided 5 is 1. 1x is just the same as x without a 1. And 15 divided 5 is 3. So we're going to have 3, and we have our a minus 2 in brackets. Now this is a good simplified response to question D. This is a perfectly fine answer. I'm going to do one more step, and you don't really have to do this. I'm just going to expand our denominator now. So 3 times a is 3a. And 3 times 2 is 6. So we get 3a minus 6. But either one of these responses is perfectly fine. Okay, we'll move on to our last two questions. You can see they look really challenging. And what makes these challenging is we're going to do a lot of factorizing, and we've got to try and use that factorizing to simplify these fractions. Okay, so straight into question E. The very first thing I want to do is I want to flip that second fraction. And I want to make this into multiplication. Okay, so we change this to times. We write 5b minus 5 above and b squared minus 4 below. Alright, now usually what I do is I combine the two fractions first and then I factorize. And I'll do this a little differently. I'll factorize them and combine them all at the same time. Whenever you multiply fractions, combining them and factorizing them at the same time can cut down your working time a little bit, and you'll find that it's actually not any harder when you do it. Alright, so we need to get into our factorizing, and it looks like every single expression here, 1, 2, 3, 4 expressions, can be factorized. So we'll start with this first one here. This is a harmonic quadratic. And when you have a harmonic quadratic, you look at the number in the middle, which there isn't one, but technically that means there's a 1. So we've got a plus 1, and the number at the end is minus 6. Right? So we're looking for something that adds to make positive 1 and multiplies to make negative 6. So what are those two numbers? Well, that's going to be 3 and negative 2. Okay, because 3 times negative 2 is negative 6, and 3 minus 2 is 1. So when I factorize that expression, I've got to have a 3 and a minus 2, which are the two numbers I have up here. And because it's b squared, I'm going to have a b here, b plus 3, and a b here, b minus 2. Okay, so we've been able to factorize this expression first. Let's factorize the denominator now. So we have another harmonic quadratic. This time the middle number is -4 and the last number is +3. So we'll follow this process again. It has to add to make the middle number, has to add to make -4, and has to multiply to make 3 or +3, which is taken from these two numbers. So what do we get? Well, it's going to be -3 and -1. -3 added to -1 is -4. And when we multiply these two numbers, we get +3 because of the double negative. So that means for our denominator, we're going to have two sets of brackets. And taking those two numbers, we've got -3 and -1. And because this is in terms of b, I'm going to have b minus 3 and b minus 1. Now, as I said before, I'm not going to write these as two separate fractions. I'm going to put the two fractions together as I factorize them. So we'll extend our vinculum line here, and let's factorize the numerator first. Factorize 5b minus 5. So we have a common factor of 5 here. 5 times b will give us 5b, and 5 times 1 will give us 5. We also need to factorize b squared minus 4, and hopefully you can see that this is a difference of two squares. We've got a minus sign, we've got two terms here, and both of them can be square rooted. So I'm going to have two sets of brackets. The square root of b squared is b, and the square root of 4 is 2. So in both sets of brackets, we're going to have a b and a 2. One's going to be a plus, and one's going to be a minus. Now that we've factorized everything and combined it into one fraction, it's really nice and easy to cancel. I've got a b minus 2 above and below. I've got a b minus 1 above and below. And it looks like I can't cancel anything else. So let's write this expression down. I'm going to write the 5 first and the b plus 3 second, because we like to have the number to the left of the brackets. And for our denominator, I'm going to write b minus 3, b plus 2. Now I think that this is a perfectly fine response for question E, but it's not going to kill us to expand this. So let's just do that anyway. 5 times b is 5b, and 5 times 3 is 15. All right, b times b is b squared. b times positive 2 is plus 2b. Negative 3 times b is minus 3b. And negative 3 times positive 2 is minus 6. Okay, and we can combine a couple of terms here in the middle, because for our denominator we've got b squared, and 2b minus 3b gives us just minus b. And then finally we've got our minus 6 at the end. Now I've mentioned this a few times already, that the factorized response is a perfectly fine answer to give. And quite often I go, well, we'll give the expanded response as well anyway, because it doesn't kill us to do it. To be perfectly honest, I personally, as a marker myself, prefer the factorized response. And the reason for that is when I look at it, I can see that there's no more cancelling that can occur. Whereas if I look at the expanded response, it's hard to tell if it can be simplified further. All right, we'll move on to our last question, question F. We're multiplying two fractions. So as we combine the two fractions, we're going to factorize them at the same time. So we'll focus first here on our harmonic quadratic. we've got a 3 in the middle and a 2 at the end. That means that we need two numbers that add to make 3 and multiply to make 2. What are these two numbers? Well, they're going to be positive 2 and positive 1. 2 plus 1 is 3, and 2 times 1 is 2. So when we factorize this, we're going to get y plus 2 and y plus 1. The plus 2 and the plus 1 come from these two numbers here. And then for our denominator, we're going to keep y plus 1 as y plus 1. I can see that we're multiplying our numerator here by y minus 2. Now I need to put that y minus 2 in brackets and then extend the vinculum bar. What do I get when I factorize this expression here? This is an example of the difference of two squares. So I'll do this in green first. I know it's a difference of two squares because I've got two terms separated by a minus, and both these terms can be square rooted. The square root of 4 is 2, and the square root of y squared is y. So my two sets of brackets are going to be y minus 2 and y plus 2. Now before I can write it down here, I need to put my y plus 1 in brackets, because all of y plus 1 is being multiplied by my y minus 2 and my y plus 2. Now, if I was to cancel, I would cancel everything. There's y plus 2, there's my y plus 1, and my y minus 2 can be cancelled as well. So what happens when nothing is left over? And you can see that people would write something such as 0 because they associate 0 with nothing, but the answer is actually 1. And if you don't know why, when you think about it, these three expressions multiplied together could have been multiplied by 1. I could have written times 1 at the end, because when you times 1, it remains unchanged. And then, after cancelling everything, I'm left with 1. Another way of looking at it is we've got the same thing at the top of the fraction as I do below the fraction. And that means it equals 1, because 5 over 5 equals 1, and 3 over 3 equals 1. So if everything at the top of the fraction and below the fraction is the same, then it must equal 1. Anyway, that concludes our video on example 3. Remember to read the description below for links to workbooklets that relate to this video.